Welcome to another session in our series of tutorials in R for data science, and in this session we're going to tackle data manipulation. And R provide one specific package called the DPLYR package that allows you to perform the data manipulation, that is the data wrangling. So there's a specific package called DPLYR that performs data wrangling. The DPLYR has its specific verbs, and as you know, verbs are doing words, that is in English, but here there are specific verbs that makes it easier for you to wrangle or to manipulate your data. And data manipulation forms up to, or it will take you nearly more than 70% of your time as a data analyst. So I will be using the DPLYR package, so you can specifically or precisely install the package DPLYR, but I usually prefer installing or using or loading the library Tidyverse. So what Tidyverse does is that it expands the vocabulary of R. So we'll start, we'll be looking at the DPLYR verbs. We'll also tackle the pipe operator, which comes with the Magritte R. So we'll also install the Magritte R datasets, and we'll be using an inbuilt dataset called mtcars, and mtcars dataset comes with the ggplot2 package. So if you want to load this package called Tidyverse, you'll have to install the DPLYR package. You'll have to install the Magritte R package. You'll also have to install and load the ggplot package, because we'll be using the inbuilt dataset called mtcars. So let's start. So we first of all install the package, that is the Tidyverse. Then we load it using the library command, or you can also use the function require Tidyverse. Require Tidyverse. You can use either require or you can use library Tidyverse. Now in DPLYR, all these DPLYR verbs, they behave in the same way, so they have the same syntax. So if you understand one verb, understanding the other verbs will be much easier. So the first argument is a data frame. Then the second argument is what you want to do with the data frame, and here you won't use any commas or any quotes. I mean, you won't be using any quotes, and the result is another data frame. And this verb, they don't change the data frame unless you create another new data frame. So let's start with the first verb we'll be learning is the filter. So what filter does is that it picks observations by their value. So we are picking certain observations using their value. So we are selecting some values in the data frame using certain conditions. So we'll be using in filter, we'll be using most of that most of our time we'll be using the comparison operators, that is greater than or equal to, less than or equal to, not equal to, and equals to. So when we're using equals to, we'll be using two equal signs. We'll also be using some logical operators, and these logical operators, they include and, the logical and the logical or, which is slash. So as I've said, we install the packages and you load the package. So let's see how the dataset looks like. So the name of the dataset is mtcars, head mtcars. You run that, and it gives you the data or the first 6 values of the data frame. Let's increase the size of our view a little bit. So let's run this again, head, and you can see it gives you the first 6 values of the data frame. Using the structure command to see the structure, we can use the structure command or the glimpse command. So let's use today the glimpse command. So the glimpse command gives you the structure or the class of each observation or each column in the data frame. The MPG datasets, as you can see, the MPG column is a double, CYL is a factor, displacement is double, HP is a double, and you can type a question mark or the help command, that is help mtcars, and it will pop up. You'll see the help of or the detail about the name of the dataset. So we start with filter. What filter does is it subsets a data frame using a certain condition. So we are subsetting a data frame using filter, or subsetting a data set with certain conditions. We can subset data frames in R traditional way. Basically, this is using the base R functions. For example, here I want to filter, or I want to subset this data frame called mtcars, in that I want all rows that has the carburetor or the carb column equals to 2. So what I'll do, I'll use the R traditional way, and then I'll also use the DPLYR package, that is the filter command. So I'm saying mtcars, and then subsetting brackets as the square brackets. Then I'm saying mtcars $sign carb equals, that is double equals to 2. So I'm asking here, I'm asking the question, I want in the data frame called mtcars, I want the column carb whereby the car carburetor is equals to 2. So I'm using two equal signs here. If I use a single sign, I'll be assigning the entire carb column should be equal to 2, which is not the case. The case here is I'm asking the question, is carburetor, or is the carb column equals to 2? That is the question I'm asking. If I run this, and as you can see here, the carb, this one, the carb is 2. All of it, or the entire rows, or all the rows have a carb equals to 2. I'm saying so. The standard way, or the DPLYR way of doing this, is I'm saying filter. Then the first argument in filter command is the name of the data frame. So I'm saying filter these data frames, or this data frame called mtcars, in that, or whereby the car carburetor is equals to 2. If I run that, still it is the same. So as you can see, this is much easier than the R traditional way. You can easily understand this than this. I'm also I'm saying filter mtcars such that displacement is greater than 360. So I want to filter this data frame such that the displacement is greater than 360. So I want a condition where the displacement is greater than or equal to 360. So that means this 360 is inclusive. This 360 should be there. If I run that, and as you can see here, the displacement is greater or equal to 360. I can also use the pipe operator, and in a little bit I'll explain what this percentage greater than percentage, or control shift M in Windows operating system. I'll explain it soon what this means. I'm saying mtcars, then I'm piping it. I'm saying filter displacement is greater than or equal to 360. This one is the same as this. If I run that, still it is the same. So you can, as you can see, you can use the comparison operators greater than or equal to, less than or equal, not equal to, and equals to. Then the logical operators, that is the and or. So I want to filter empty cars such that miles per gallon or mpg is equal, is greater than 20, and the am is equal to 0. So I'm using and the logical and here, using the logical and. So and will give me a condition whereby both these conditions are true, where miles per gallon is greater than 20 and am is equal to. Both of these two conditions must be fulfilled first of all, then or it will return the values where these two conditions are true. So run that and see. As you can see, the mpg is greater than 20, the mpg is greater than 20, and am is equals to 0, and am column is equals to 0. Then is the logical or. The logical or it will return in either condition, whether either this is true or this is true or both are true. So that's the difference between the logical and the logical or. And as you can see here, as you can see, the mpg here is greater than 20, mpg is greater than 20, and am is equals to 0. But here am is equals to 1. Why is that true? Because the logical or returns a value in either or under the condition whereby either this or this is true. Then this is not equal to. So I'm saying filter empty cars where am is not equals to 0 and gear is greater than 4. So basically I'm saying I want where I want the condition whereby am is equals to 4, or am is equals to 1, sorry, am equals to 1 and gear is greater than 4. So this means not equal to. So let's run this and see. As you can see here, this one is saying sorry, gear is greater than 4. I'm saying that not meaningful for factors. Actually we can't. Let's change this. Let's change this from gear maybe to let's mpg is greater than a certain value. Let's say is greater than 20. Let's run that and see. And here it is. So I'm saying where am is not equals to 0, as you can see, am is not equals to 0, and miles per gallon is greater than 20. This is the same as this. If I change this from gear to mpg, so this one, this line of code, that's line number 54 of the code, and line number 57 basically does the same thing. Now one thing to notice that the logical and the logical or does not work as in English. So you can't say filter empty cars carburetor is equals to 2 or carburetor is equals to 4. This one is wrong. This one is wrong. Let's see what this does. And as you can see here, we have the car carburetor with the value 3, with the value 1, and as we have said here, we have specified that we want the car carburetor where the car carburetor is equal to 2 or 4. We only want 2. We only want 2 or 4, but here we have 1. This is how the logical and or the logical or behaves. So you see, filter empty cars, you specify the car carburetor is equals to 2 or car carburetor is equals to 4. You can't do it this other way, but this is the correct way to do it. And you can see it has 2, 4, 2, 4, 2, 4 only. The second verb we'll be looking at is the arrange. So we are arranging rows. So it changes the order of rows. It arranges rows in descending order by default. Here I'm saying arrange empty cards. So the first argument, as in filter, is the name of the data frame, but then the column in which you want to arrange it. So I want to arrange empty cards using miles per gallon in ascending order. Let's run that and see. And as you can see, it has arranged this data set using this column called miles per gallon, and it is in ascending order, so it is increasing as you move downward. You can specify multiple columns which you want to arrange the data frame using. So I'm saying arrange empty cars using HP, using the HP column. This is the HP column, and the WT or the weight column. And I'm saying I'm adding the pipe operator here. So this percentage greater than percentage and head. So what this does is that it chains, or it adds this head command into this function. So it will give me the first 6 values. And as I've said, I'll be explaining shortly what this pipe operator means. So let's run that. And here it is. It has arranged this data set first of all by HP. It has first of all arranged by SP. As you can see, HP is increasing as you move downwards. Then after arranging it with this, so if there is a conflicting value, it will then use the WT in arranging it. I'm saying arrange empty cars, but here I'm saying in descending order. So I want this in descending order. So it will arrange this data frame using this column in descending order. And I'm chaining this command, or I'm piping it to the head command. And here it is. It has arranged using the car carburetor, but in descending orders. The third verb is looking at is the select. So we are selecting. It allows you, or we want to select the columns in which we want to work with. For example, here I want us to select. For example, we want to use the mile per gallon, displacement, the HP, and drat column. So we want to work with these columns. We don't need the other columns. So we're saying select, then the name of the data frame, which is empty cars, then the columns in which you are interested in. Then I'm chaining into head command so that we'll have 6 values. Let's run that. And as you can see, it has given us the columns, or the data frames, or the columns in which we're interested in. And remember, we can assign this into a new data frame. For example, we can say new underscore data, and new data is selecting this data frame. And so that means we'll remove this, and we'll also remove that. And if we run this, this is the new data, so we can as well look at the new data by running it. And here it is the new data frame which has been created. So we can also select using full column, that is from VS to the car carburetor. So we want to select from VS to the carb. Then I'm chaining it, or I'm piping it to tail command. So tail, the last 4 values will give me the last 4 values. If I run that, it will give me the last 4 values of this column. So from VS to the car carburetor. I can also select everything except HP, the car carburetor, CYL, and HP. So I negate, I'm saying select, then empty cars, everything in this data frame except HP, the car carburetor, CYL, and WT, by introducing a negative sign here. I run that. And here it is. It has isolated this value. I can also select that ends with, that begins with. So I'm saying select empty cars that ends with L, and I'm chaining it to head command. And as you can see, it ends with with L. The only value that ends, or the only column that ends with L, is the CYL column. Also, that the one that starts with G, the only one that starts with G is the gear column, and as you can see, it is the only column here. Also the one that contains letter E, so let's run that, and the one that contains letter E is gear and qsec. Let's add new variables with the mutate. So then another function we are using here, or we are learning about, is the mutate command. What the mutate command does is that we are creating new variables, we are adding new variables. So I'm saying mutate, then empty cars. Then I want to create another new variable called speed, and speed is defined as the distance divided by the time. So this displacement is the distance, that's the distance. And then qsec is the time taken to cover a quarter a mile. So I'm saying mutate empty cars. I'm creating a new variable called speed. Speed is equals to displacement over the q seconds multiplied by 4, because this is a quarter a mile. I'm multiplying it into that is the distance taken to cover 1 mile. So if I run that, you see a new variable here is created called speed, and here it is. So what mutate does is it creates a new columns. It creates another new column. The fifth verb we are learning is summarize. So what summarize does is that it collapses, or it breaks down an entire data frame into a single value. What summarize does is that it allows us to perform some basic arithmetic. For example, the mean, the variance, the minimum, the maximum, the median. So if I want to perform the mean of the entire miles per gallon column, that is the MPG column. So I'm saying summarize empty cars mean of MPG. So what this perform is that I want the mean of miles per gallon. And here it is. This is the mean of MPG. I can also summarize empty cars. I want the variance of the displacement. Summarize on its own does not perform great. It does not. It's not of that great importance on its own. But if we use group by with it does, or you will realize the magic that summarize can do. Same as mutate. Mutate also does well with group by. So what if I want the mean? I want the mean of cars, or I want the mean of miles per gallon of these cars, but per each CYL. As we had seen earlier, CYL is a factor, so it's a categorical variable. So I want to see which car model has the largest mean, or has largest miles per gallon mean. Which car model or which CYL car consumes a lot of fuel. So I'm creating a new data frame here called group underscore CYL mean. I'm saying group by. So what group that it will take this data frame empty cars, it will group it by CYL. If I run that, so now I want to summarize this. I want to summarize now. So basically this has been this data frame called empty cars, it has been grouped by CYL. So here I'm saying I want to summarize this new data frame, but based on the mean of MPG. I run that, you can see now here the cars with CYL4 is the mean of its MPG. The cars with CYL6 and the cars with CYL8. The easiest way to do this is to chain it using the pipe operator. Now let's introduce the pipe operator. Now the pipe operator is from the MagritR package. What the pipe operator does is that it chains commands. It chains commands. So by chaining command, what do I mean by that? The easiest way to write a function is using the pipe operator. So what the pipe operator does is that it takes the first or the first argument or the first variable that I've provided. For example, here I've provided empty cards. Then it takes this value and it places it here as the first argument of the second function. Same as it takes this value, it pipes it here as the first argument of this function. As you can see, group by, the first argument of group by normally should be the name of the data frame, then what you want to do with that data frame. But what pipe operator does is that it allows R to take the first argument or the variable that are provided here or the data frame, which is empty cars, then it pipes it as the first argument in the second function or in the second function. That is what pipe operator does. So here I'm saying empty cars, I'm piping it, so I'm piping it to group by COIL and then summarize. This is the mean of the MPG. Let's run that and you can see it performs the same function. So that is what pipe operator does. So I'm saying here empty cars, then I'm piping it to group by. I want it to group by the carburetor. Then I'm piping it. I want to select the curb, displacement, the QC. I'm also piping it again. I'm creating a new variable here called speed. Then I want this to summarize it by the variance of the speed. Let's run that. And here it is. There's no variance for 6 and 8. Another function we are learning is the relocate. What relocate does is it moves a column before or after specific column. So I'm saying empty cars, I'm typing it to relocate command. I want to relocate the curb then before my column. So I want the curb to be the first argument or to be the first variable in this in the new data frame. I'm piping it to head command, and here as you can see it has been moved as the first argument. I can also move it after. So I want to move from VS to gear after displacement. So I want it to be here, these 3 columns. Let's run that. And as you can see, they have been moved to after displacement. Another function is slice. So slice allows you to index rows by their integer location. So it allows you to select the row you need. So I'm saying empty cars slice 5. So I want the first 5 variables. And as you can see, it has given me the 5th row. So it allows you to index rows. So I want here the I want the 5th row. So this is the 5th row. I'm saying empty cars slice head. So slice head, what slice head does is that it will give you the first 2 rows. Slice head, so I want the first 2 rows. I'm specifying n is equals to 2. If I run that, it will give me the first 2. It is the same as saying head, then empty cast the first 2 variables. Then you can also use slice tail and you specify the rows that you want. You can, it's the same as tail empty cast. There's also another function called slice underscore sample. What slice underscore samples, it randomly selects samples, but it will give you the number of samples you want. So I want 7 samples. So I'm saying empty cast. Then I want to select these columns. I'm piping it to arrange. I want to arrange by COIL, that is in ascending order. Then slice sample 7. That is it. Then there's, lastly, we'll look at rows. Now, rows basically works best with a cross. So it allows you to perform row-wise operation. It allows you to perform row-wise operation. For example, you want the mean, or you want the variance, or you want the minimum of a certain row. So I'm saying empty cars. Then I want a row-wise operation across all the across all the columns, or across all the rows. So I want the mean of all the rows, but I'm saying summarize. So let's run this and see. And here it is. So it has performed the mean of all the rows. So this is the mean of the first row, the mean of the second row, third row, and so on. What row-wise does and see across is that it performs the row-wise operation, and it works best with summarize and mutate. Also, I'm saying empty cars here. I want to select mpg, displacement, and qsec, and then I want to perform row-wise operation. I want to summarize row mean. So this is the row mean. I'm saying see across everything. So let's run this and see. And as you can see, it has performed the mean. It has performed the mean of miles per gallon, displacement, and qsec. That is what row-wise does. So basically, those are the few, or those are some of the most widely used DPLYR verbs. So I hope you've gotten something in this session. So let's meet in our next session. Enjoy learning.